this paper, we present a novel image dataset of grocery store items, which can be used for image classification. My name is Marcus Claesson, and I am a PhD student at KTH Royal Institute of Technology, and this is joint work with Chong Chang and Hedvig Källström. In recent years, a variety of assistive vision devices have been released on the market for helping visually impaired people with, for instance, reading text and recognizing faces, but also identifying grocery items from barcodes. However, the barcode approach has some limitations. Firstly, without being able to see, it can be hard to find the barcode. And secondly, some items do not have barcodes at all, for example fruits and vegetables. We stress that the ideal goal for assistive vision devices to recognize objects is by relying on natural images, for example, images taken with a smartphone camera. When designing a vision system that should be used in a grocery store to find items, there are two situations that we need to consider. Firstly, since fruits and vegetables don't have barcodes, we cannot use a barcode recognizer to separate red apples from green ones. Therefore, the system must be able to distinguish between similar items in terms of color and shape. Secondly, misplaced items can occur in the store, so the system must be usable for images with different kinds of objects present. In order for our vision system to be robust to these scenarios, we need data that illustrate these situations. Since we couldn't find any datasets addressing these situations, we decided to collect such a dataset on our own. All images in our dataset have been collected by visiting different grocery stores and taking photos with a smartphone camera. We ended up with over 5,000 natural images from 81 different classes of fruits, vegetables, and carton items, such as juice and dairy products. The 81 classes are divided into 46 coarse-grained classes in order to establish a hierarchical structure in the dataset. For example, apple is a coarse-grained class, and the fine-grained apple classes Royal Gala and Granny Smith belongs to this class. We split all natural images into a training and test set with respect to the geographical location of the grocery stores. Since collecting the natural images is time-consuming, we wanted to investigate if model performance could be improved by using additional data formats related to the grocery items. Therefore, we downloaded iconic images and product descriptions from the web for each fine-grained class. We obtained benchmark classification results by fine-tuning 3 different pre-trained CNNs. The best classification accuracy we achieved was 84% from a DenseNet 169. To utilize the iconic images, we use a deep generative model that we refer to as variational autoencoder canonical correlation analysis, which treats both natural and iconic images in 2 separate views that are jointly generated from a single latent variable. We trained the VAE CCA model by extracting image features from a pre-trained CNN, then encode the features into the latent space, and finally we use 2 separate decoder networks that respectively reconstruct the image features and their corresponding iconic image. We then perform classification by training an SVM on the latent representations of the natural images. We compare the VAE CCA approach to a standard VAE that is only trained to reconstruct the image features, and see that using the iconic images improves the SVM's classification performance. Another advantage with VAE CCA is that we can inspect the latent representations of unseen natural images by decoding the representation through the iconic image decoder. In the bottom figures, we have taken natural images from the test set and translated them through this decoder network. We see that the model can decode the iconic image of the target class almost perfectly, even if there are some misplaced items or much of the background in the images. For the image with oranges, the decoded image is a mix between an orange and a green apple, which indicates that the natural image has been encoded close to the boundary between oranges and green apples in the latent space. In conclusion, we have collected a dataset with natural images from grocery store environments, which can be used for evaluating image classification models. We have also collected iconic images and product descriptions for each class and proposed a multi-view generative model that utilizes both natural and iconic images. In the future, we aim to investigate how the product descriptions can be used to improve classification performance, explore other types of architectures and multi-view models, and also collect more natural images. Our dataset is available on GitHub. Thank you for watching this video.